we've seen that if we have two straight lines and a line crosses through them, that line is called a transversal. And before, we saw that if we know they're parallel, if we're told that two lines are parallel, like with these lines, we can figure out the angle. This situation over... This situation over here is different. We do have a transversal and we do have two straight lines, but we are not told whether the lines are parallel. It's not given that the lines are parallel or not. And the diagrams aren't to scale, so you can't even look at it and think, oh, okay, these don't look parallel. I guess they're not. Our job is to figure out whether they're parallel and to prove it, to make a solid argument that someone else can follow of whether they are parallel or are not parallel. So what we'll do is for each diagram, we want to prove whether the line going through A and B, so this line here, is parallel to the line CD. We want to prove whether these are parallel. All right, first one, I've got the transversal here, the line, and I've got two angles here. There's this one and this one. They're both on the top left relative to the dot. So are these corresponding, alternate, or co-interior, or none? These two are corresponding. I've got two corresponding angles. Maybe they're equal, maybe they're not. Maybe the lines are parallel, maybe they're not. But they're definitely corresponding angles. Okay, and these are 190 degrees. The rule says that if they're parallel, and only if they're parallel, that these must be equal. Are these two numbers equal? No! So therefore, it cannot be parallel. So my argument here, my proof that will convince someone else, someone can read this and follow along and understand, you know, if they've done Year 8 maths. I've got corresponding angles. They should be equal to be parallel, but they're not. Therefore, they cannot be parallel, because if they were parallel, they'd be the same. That's the argument. Let's try another one. This one here, again, I've got a transversal. This line here crosses the AB and CD. So I've got this angle and that angle there. They're both between the two straight lines and they're both on the same side of the transversal. So do I have corresponding angles, alternate angles, co-interior angles, or none of those? I have co-interior angles. And co-interior angles, just to be clear, these are 118 degrees and 62 degrees. If these lines were parallel, if AB was parallel to CD, then they should be supplementary. They should add up to 180 degrees. And in fact, are these supplementary? 118 degrees and 62, do they add up to 180? Yeah, they do. So therefore, it must be parallel. Because if the co-interior angles add up to 180 degrees, then the line must be parallel. If we got something else here, like 190 degrees, what would we conclude? If we got 190 degrees, we would have to conclude that they're not parallel. So you can see that these theorems can be used in two ways. You can use it to determine whether two lines are parallel, and normally you do that when you're not told that they're parallel. And you can also use it to determine one of the unknown angles. So I hope that has helped give you a little taster of what a proof is. And as always, ask me if you need a hand. I'm happy to help out. Try lots of questions, check your answers, and make sure that your communication is really clear, that you're giving a reason, explained, whether it's true or false, and your final conclusion. Therefore, are they parallel or not parallel? If you just write this word here, or these words, that's not enough. You have to have the whole argument. All right. Good luck, everyone. Bye.